So for this next example, this is how it's supposed to go. You're supposed to figure out which one is your u and which one is your v, dv. So using Liate, as we can see, we have an algebraic function and an exponential function. So obviously algebraic comes before exponential. So you will let your first function be u, and then the next function be dv. Then the formula for integration by parts is uv minus integral of v du. So all we need is to find the values in the formula. Now, if our u is equal to x, then what is our du dx? Our du dx is 1. If our dv is equal to exponential x, then what is our v? If you integrate exponential x, you get exponential x. Okay, so now we replace the values in the formula so that you can be able to work out. So uv, our u is x, multiplied by our v, which is exponential x, minus integral of v, which is exponential x, multiplied by du. And our du, if you make du the subject of the formula here, it will be equal with dx. So our du in this case is dx. And this is x exponential x. If you integrate exponential x, you get exponential x as well, plus c. And that's how you go about it. Now, you can be given a question which involves integration by parts, and probably you now have to do integration by parts twice because the question probably has a square. So let's say, for example, you're given a question like this. Find the integral of x squared cos x dx. Now, using Liate, we determine which function will be our u and which one will be our dv. We have an algebraic function and a trigonometric function here. So our first function obviously is the u, and our next function is the dv. Then the formula is uv minus integral of v du. So what do we have? We need to identify what our du is and what our v is. Now u is equal to x squared. So what is our du dx? If you differentiate this, you get 2x. And dv is equal to cos x. So what is our v? If you integrate this cos x, in order for you to get the value, the integral of cos x is sine x. Then replacing these values into the formula, so you're going to have, replacing the values into the formula, we will have uv, our u is x squared, multiplied by v, which is sine x, minus integral of v, sine x multiplied by du. And our du, look at this, making du the subject of the formula, we will have 2x dx. So what does that give? I'm going to rearrange this so that I have x squared sine x minus integral of 2x sine x dx. The reason as to why I'm writing the 2x before the sine x, because we know that if you're using Liate, then algebraic function is going to be your first function. Then here we have to now use integration by parts again, because as you can see clearly, this is two functions. So let this one be your u. So let this first function here be your u, and let this other function be your dv. So using integration by parts again, we are having x squared sine x minus, integrating this side, we'll have uv. So what's going to be our u? We can evaluate it right over here. Our u is equal to 2x. That makes our du dx 2. Our dv is equal to sine x. That makes our v be equal to minus cos x. Okay, so replacing these values into the integration by parts formula, I have, this is what I'm integrating at this instant. So x squared sine x minus uv. So let me just write it here, uv minus integral of v du, because I'm using integration by parts again. So I'll have x squared sine x minus uv. What is our u? Our u is 2x multiply minus integral of v. Our v is minus cos x multiplied by du. And our du, if you make du the subject of the formula here, it is equal to 2 dx. So evaluating that, simplifying, we'll have x squared sine x minus 2x, and then minus, minus, minus. So that will give us minus. Here on this other side, we have 2. I can take it outside. And then the derivative of cos, the integral of cos x. If you integrate cos x, you get sine x plus c. And that becomes your answer. So I hope that's clear. In a similar manner, you guys can do this one. Integral of x squared exponential a half x dx. So for this particular question, this is how you go about it. So if you're using Liate to help you get to know which function you're choosing as your first one and the second one, this is an algebraic function and this is an exponential function. So as you can see, algebraic comes before exponential. So let this one be your u and let this one be your dv. Then the formula is uv minus integral of v du. So I'm going to identify values that I need in the formula. If u is equal to x squared, then what is du dx? Du dx is equal to 2x. Okay. Now, dv in this case is equal to exponential a half x. So what is v? V is equal to a half exponential a half x. So replacing these values into the formula, we have uv. Our u is x squared multiplied by v. Our v, as you can see, we've gotten it to be a half exponential a half x minus integral of v. Our v is a half exponential a half x multiplied by du. Our du, as you can see from here, is du is equal to 2x dx. So we have this as 2x dx. Okay, so this just simplifies to a half x squared exponential a half x. I want to rearrange whatever is inside the integral sign. So this 2 can go with this. And then I have x exponential a half x. I am writing x to be the first function because of Liate. If you have an algebraic function and an exponential function, the algebraic comes first. Then here again, I'll have to use integration by parts again on this part here. So I will let this be my u, and then I will let this be my dv. Then this will give me a half x squared exponential a half x minus uv. So our u is x multiplied by our v. So we can find the values from this. If our u is equal to x, du dx is equal to 1. If our dv is equal to exponential a half x, then v is equal to, if you were to integrate this function, then you will get, so the integral of this is actually exponential a half x over a half. And I need to make a correction because when we were integrating it here, this was supposed to be over a half. So right here, this is exponential a half x over a half. That's how we go about integration. Okay. So now that we have that, let's see what changes, because here we had the uv. So our v here as well was supposed to be over a half. So all this over a half, and here as well, this is supposed to be our v is exponential a half x over a half. So this 2 will remain because 2 divided by a half will give us a 4. So this that will be just 2. So when we come to this other side, so we will have, instead of a half here, we will have 2. This will be 2x squared exponential a half x minus the integral of, so on this other side, we needed to have v du, and our v du was exponential a half x over a half. So what we need is, we are rearranging this, and this is obviously going to give us, on this other side, this is going to give us 2. And then on this other side, we have 2 divided by a half, so that will give us 4. So here we'll have 4. I can write the 4 outside, so that now we continue with our evaluation. So now, having that, we can continue and evaluate the next part. So this is 2x squared exponential a half x minus, we need uv minus integral of v du. So u is x, v is exponential a half x over a half minus integral of v du. Integral of our v is exponential a half x over a half multiplied by du. And what's our du here? Our du is the same as dx. So that translates to 2x squared exponential a half x. Opening this, we will have minus 2x exponential a half x. And then opening this, we will have minus 2. If we integrate exponential a half x, we will have exponential a half x. All this divided by a half. Okay, plus c. But let's not forget, over here we had a 4. So this 4 is supposed to be out here, and it's going to affect all the values from this. So the 4 is going to be right outside here, minus 4. So that's just about it. That's how you're supposed to go about integration by parts. You guys can try out this example in a similar manner. So you first of all check if the functions are in the right order, so that you can be able to know which one to pick as your u and which one to pick as your dv. Now we have an algebraic function and a trigonometric function, and algebraic should come before trigonometric. So this will be your u and this will be your dv. And the formula is uv minus integral of v du. So having that, we're going to identify values to put in the formula. If u is equal to x squared, then what is du dx? Du dx is 2x. If dv is equal to sine x, then what is v? In order for us to get v from dv, we integrate. The integral of sine x is minus cos x. So now, replacing the values in the formula, uv, our u is x squared, multiplied by our v, which is minus cos x, minus integral of v, our v is minus cos x, multiplied by du. From this, you can be able to see, if you make du the subject of the formula, you'll have 2x dx. So rearranging this, we will have minus x squared cos x, minus will give a plus, and then I'm going to rearrange the values inside the integral sign. We have cos x and 2x. So 2x will come first, and then cos x dx. Now, right, this step, we are going to use integration by parts again. So we are going to let this be u and let this be dv. Clearly, this is algebraic, this is trigonometric. So if you check here, the algebraic should come before the trigonometric. So having chosen our u and dv, this is dv, we need to get values du and v. So u is 2x. So if u is 2x, what is our du dx? Our du dx is 2. dv is cos x. So what is our v? If you integrate cos x, you get sin x. So these are the values we're going to replace in the formula. So we are going to have minus x squared cos x plus, now carrying out the integral of this, we are going to use the integration by parts formula uv. So our u is 2x multiplied by v, which is sin x, minus integral of v sin x multiplied by du. And if you look, du will be 2 dx. So simplifying this, we will get minus x squared cos x minus x squared cos x plus 2x sin x minus, I can take the 2 outside, and then the integral of sin x is minus cos x. So minus minus will give me a plus cos x plus c. So that's how we go about that particular question. You guys do number 6 now. Try and be a little bit fast. So number 6, let's evaluate the integral of x squared cos 2x dx using integration by parts.